Welcome back to the deep dive. We love digging into those surprising facts, hidden complex topics. And today, well, we've got something that sounds a bit like science fiction, honestly. We're talking about
Mhm.
getting energy from rain. Yeah, you heard that right. Rain. Okay,
Yeah.
let's unpack this a bit. So picture a solar panel, but one that doesn't just, work when it's sunny. It actually generates power when it's raining. Sounds wild, right?
Mhm.
But it seems very real. This is the idea behind rain-powered solar, a hybrid solution from Black Knight Power. And we're going to explore how this tech could be a real game changer for cities, especially somewhere like Bridgeport, Connecticut.
It's fascinating, really, how these systems manage to grab energy from both sunlight and rain. It tackles one of the biggest headaches with solar, right? The intermittency issue.
Exactly when the sun goes down or behind clouds.
Precisely. So the core tech, it basically merges standard photovoltaic cells, PV cells, with these things called triboelectric nanogenerators, TANs for short.
Tans.
Yeah. And when raindrops hit the panel surface, which is often coated with something like FEP, that's fluorinated ethylene propylene.
Okay, some kind of special coating.
Right. It's durable, low friction. The impact and friction generate tiny electrical charges. It's called triboelectrification, like static electricity, rubbing a balloon on your hair, that kind of thing.
Ah, okay. I get it.
So it's this clever dual layer setup, top layer for the rain energy, bottom layer for the usual solar energy.
That really does sound like turning a problem into a plus,
Yeah.
making solar just more robust, I guess.
Exactly.
So the benefits compared to just regular solar panels are pretty clear then.
Definitely. You get much higher energy yield overall because it's working even when it's cloudy or pouring rain. More consistent power.
Right.
Then there's durability. Those coatings make them tougher against weather, which is, super important for coastal areas dealing with storms.
Yeah, makes sense.
And kind of a side benefit, you could potentially collect that rainwater runoff, maybe use it for irrigation or other city needs.
Water conservation, too. Interesting. And thinking about Bridgeport, Connecticut, that seems like a perfect test case.
It really does.
They get, what, about 47 inches of rain a year? That's more than the U.S. average.
Mhm.
And they're on the coast. They've dealt with hurricanes like Sandy back in 2012. So this tech seems almost custom-built for their climate.
And if you look at the bigger picture, yeah, the upfront cost is a bit higher. The source estimates maybe $3.60 to $4.25 per watt, compared to like $2.85 to $3.25 for traditional.
Okay, so a noticeable difference.
A bit, yeah. The panels themselves cost more per watt too. But, and this is key, the efficiency is better. We're talking 18 to 25% versus maybe 15 to 22 for standard panels.
That's air efficiency, right?
And critically, because it generates power more consistently, you might need less battery storage. That helps balance the overall cost equation.
Ah, okay. The storage angle.
Plus, you can't forget the financial incentives. There's the federal 30% tax credit, the ITC. And Connecticut has its own zero program for renewable grants. That makes a big difference in accessibility.
Absolutely. Incentives are huge. And this is where it gets really interesting for Bridgeport specifically. They're not exactly strangers to solar innovation. Remember that Seaside Park landfill project back in 2013?
Oh, yeah, the landfill conversion.
Right. A 9-acre-old landfill turned into a 5-megawatt solar farm, over 1,000 panels. That project alone cuts something like 6,000 tons of co-euros yearly. Shows they can do big solar projects, even on tricky land.
It definitely proves their readiness.
And the source we looked at suggests that if you retrofitted existing solar farms, like that one in Bridgeport with these 10 layers, you could boost their output by maybe 15 to 20%, just leveraging all that rain they get.
Wow, that's significant.
So, yeah. What does this really mean for the future of energy in cities?
Well, it means these hybrid systems, like the Black Knight Power Tech, are a really powerful tool, especially for rainier climates, obviously, maximizing that energy yield. And importantly, we don't just have to build new ones. Retrofitting existing solar farms could speed things up quite a bit.
Good point. Use what's already there.
Exactly. And with those incentives we mentioned, plus technology costs generally trending down, well, these systems should become much more common, more accessible, probably by 2030. Making the whole grid more resilient.
It's quite a shift in perspective, isn't it? This deep dive really shows how something we usually see as negative, a rainy day, could actually become a real asset for generating power. Makes you wonder what other everyday challenges or, overlooked things might hold some hidden potential if we just looked at them a bit differently. Thanks for joining us on this deep dive today.